Okay, so now what we're going to do is we've got our process data, or at least partially processed data. We're not quite done. You have entered your group's trials into the lux versus rate. If you're in the morning or afternoon, it'll be a different tab. So once this is all entered and we have the group data here, we essentially have all of our rates calculated for each trial for each light intensity. So our independent variable is light intensity. Our dependent variable is rate of photosynthesis. Our goal in any lab is to end up with a graph that graphs our y, our x will be our light intensity versus our y would be our rate, or our dependent variable. So we've got our independent versus our dependent. So, but we're not going to just graph the trials. We want to do averages. We want to do the mean rate of photosynthesis at each light intensity. So what I'm going to work on here is I'm going to actually put this into Excel, because Excel will allow us to add the standard deviation bars that we want. So I'm going to copy that data, the class data. I'm going to go to my Excel workbook and I'm going to paste it in there. And again, we've got light intensity independent variable, rate is dependent variable. So I'm going to copy my independent variable here. And then I'm going to have the mean, I'm going to move it down a little bit. Sorry, because I already have some cells that are, okay. So then I've got my rate of photosynthesis here. We can do that. And then I'm going to do my mean, and I want my standard deviation. So to calculate the mean, I'm going to do the mean for the first light intensity. I'm going to go up and I'm going to double click on that FX up here on that bar. And then I'm going to find the average. I'm going to double click the average. Now it's suggesting to me, oh, do you want to take the average of B16? Which obviously no. So we want to take the average of all of the trials for this light intensity. So you can just erase what their suggestion is and then come over here and you just highlight the trials that you want to do the average and then hit done. Okay. And it's so nicely intuitive. I can just pull this down and it should know that I want to do that for all of my light intensities. And you can go and double check, like for the 2000 for this one, that gives me 6.66. I'm going to look over here. It says that it's giving me the average from C10 to G10. And so I can click on that and yes, it highlights the correct ones that I want. Oops, I just did a stray click. Let me just erase that stray click. Okay. It's not happy with me. You'll have to forgive my stray clicking. All right, done. There we go. All right. So now to get standard deviation, it's very similar, except you want to look for, you might need to go into the search bar and type in STDEV. So I'm going to double click my standard deviation. Again, I want to give it the exact same values because I want the standard deviation of those trials. Okay. And then I'm going to drag it down and voila. Okay. So now what we're looking for, again, in any lab, you want to graph your independent variable on the x-axis and your dependent variable on the y-axis. So here is my x, here's my y. I'm going to highlight them. I'm going to insert an xy scatter. And I want to double check to make sure that this looks right, because check your x-axis. Does that look like light intensity? Yeah, I think we're good. And your y-axis should be somewhere with the means. So starting at 2, yep, and the max one looks about like 6.66, so about there. All right, so we're good. And it's graphed it correctly. You can just highlight and delete that because you don't need the mean title up there. Again, doing your axes titles. So if we do our primary horizontal, that's going to be light intensity in lux, right? You'll do the same thing for the vertical axes, and that is going to be your rate of photosynthesis. I'm going to just go a little bit, and then you got your units, percent T, I'm doing it like this, even though you probably want to use SI units. Minutes for -1. Okay, so this looks good. We've got those. Now we want to add a trend line, of course. And besides the trend line, we would also want to add our standard deviation error bars. Let's do the trend line first. This is a little bit wonky because most of the time when we do trend lines, we have either linear, trend lines, or we'll do something like a polynomial where we're looking for a maximum. We aren't, and so we aren't going to be doing that because it should be leveling off, right, with light intensity. So we don't have a maximum and it's not behaving linearly. One option in doing a trend line would be to choose a logarithmic one, and we'll talk about the merits of that here in a second. So I've clicked on my data and I want to add a trend line. There's two ways you can add a trend line. You can right click on the data, and where it says add trend line, you can go there. And that's one of my favorite ways to do it because it usually brings this up almost automatically. But if we didn't do it that way, I'll erase my trend line and just show you another way to do it, is you go to the add chart element and you go to trend line, and it forces you to pick one of these. So I'm just going to pick linear for now. I'm not that psyched about a linear trend line because that doesn't seem to represent my data. But if you double click on the trend line itself, it'll bring this over. So there's two ways to approach it. All right, so we don't want linear. We want to, maybe let's try a logarithmic. And I know that it's actually not going to let me do it because I've got a 0 there. So I'm going to just cheat a little bit with this and put a 1 in here for now because otherwise it wouldn't let me pick a logarithmic. So I just replaced my first light intensity with 1. So if I want to do logarithmic, I can, and it gives me a logarithmic. It's not that beautiful. And you can see if we hit display the equation and our R-square value, that's what we would get. You could try to pick another type. You could maybe try a polynomial or something along those lines, but it's your call. So the R-square value is going to represent, for us, that's how closely our data points fits this logarithmic line. You could also, kind of draw a roving average if you'd like to do that as well, kind of showing where it levels off, because it's kind of nice because it looks like in this example it's leveling off nicely. We'll see if your data does that too. So again, looking at the trend line options, some other ones, that one looks pretty nice, but we know it's technically not a polynomial because it shouldn't drop back down again. So even though it fits it well and gives us a really nice R-squared value, we know that it should keep going linearly rather than dropping back down. So you can play around with that, but whenever you have whatever you choose for your trend line, you need to have a reason that you're choosing it. And usually you want to have a biological reason for making that decision. Okay. So should your data be moving linearly? Should it have a peak, like a minimum or maxima? So always make sure you're picking the trend line that works for biologically for your data. Okay, and you will need to justify that in your analysis section. All right, let's move on. Let's go to adding the error bars. So just like that before, you can either right click and go to select data, and right click, and it should be data series, format data series. And that is one option to add your error bars. But another way you can do it, which let's go over to the add chart element. If you go to error bars, now you might be tempted to pick standard deviation, and I would, because that's where we're started, but we're not going to stick with that because wow, look at what happens. So if you go over to add chart element and pick, standard deviation, it's going to give you the standard deviation of your X and Y, but it's also going to give you the standard deviation of the totals. And let me show you what I mean by that. So first of all, we don't want our standard deviation for our X values. So I'm just going to highlight the X error bars and I'm just going to delete them. I don't want them there anymore. And now looking at the ones that it's giving us for our standard deviation for our Y, that's not right, is it? It's all the same when that's definitely not representative here. So when I click on my error bars, if you double click them, it's going to give you some nice options here. So we want both, we want cap, but we don't want their standard deviation. We're going to go to custom and we're going to specify the value. And so then this will come up and we're going to highlight here our standard deviation. You'll again replace this, highlight the same bit. So we've got the same thing here and there. It's our standard deviations. You hit OK. And then it adjusts them accordingly, which is nice. So you can see that 0.97 for our first one, it's really big here. Whereas the, kind of a medium one, 0.55, the smallest one over here. So we have the appropriate standard deviations. All right. So we have all that together. Then you can copy and paste that into your Word document or your Google document to complete your analysis section.